Okay, so for our indie lab, I have this person in my family who has a computer, and it kind of sucked. And he wanted me to build him a new one, so I did. But that wasn't my indie lab. And then the indie lab was overclocking it to make it do better, like make it compute better.
And so overclocking is the process of forcing a computer to perform at higher frequencies than set by the manufacturer in order to make it perform better.
And these are pictures of it. That's what the case was, and that's what it opened. And the two experiments we did were, I guess it's kind of three experiments. The first one was overclocking the processor. And we did that, like, the manufacturer gives you a tool to do it, and then, like, there's a way that you can, like, go in and do it manually. And then we overclocked the graphics card, too, with stuff. And these are, like, all the tools we use, like monitor, like, power, voltage, and current, and temperatures, and speeds, and frequencies, and all that cool stuff. And this is the processor, and that's the picture. So you can talk about this.
Okay, so the first method was the turbo boost method, and that was just to increase like the base frequency that the processor was using. And then with the manual overclock method, we were actually increasing the number of cores that were active in the processor.
And this is raw data from method 1. Something that's really cool about this is like when the processor doesn't have enough voltage to operate, it doesn't boot. So like all the ends you see means that like there wasn't enough voltage going to the processor to like start the computer. It would like try to start and then explode, or like shut down and restart, not explode.
Well, sometimes it would start up then, but then it didn't actually have enough voltage, so it would crash once it started up.
Yeah, so all these Y's are when like it started and then it stopped because it didn't actually have enough power, but it thought it did.
So these are different runs that you've made, and you've tested each attempt?
Yes.
Okay.
Yes, and then this is the same thing for this second method, and then these are all when it crashed, and then, yeah. So these are all our hypotheses for the processor overclocking. Hypothesis A was that the core voltage will limit performance increases of the processor, so we'll have to increase the voltage as we go up in frequency.
And hypothesis B was that the higher core voltages we use, the CPU temperature would grow exponentially.
And then we thought that processor performance will show diminishing returns as you get higher. Like as we reach the physical limit that it gets to, it'll like have diminishing returns. Like it'll be inverse exponential.
And then our last hypothesis was we thought that we'd be able to get the CPU running at 20% better than the manufacturer had it.
And this is just a cool graph. This is from our graphics card, not the processor. But the fans of both the processor and graphics card both work like this. Like the fan speed goes up as the temperature goes up. And then, so that's really cool. So like if you get like to 60 degrees Celsius or whatever, it'll be like its fan speed going faster than if it was at 40 degrees Celsius. But then like when you're cooling down, it's really weird because like the fans will be going really fast and you'll like hit a sweet spot like right here, and then the fans will slow down significantly, and then the temperature will go back up, and then cause the fan to speed back up. So it's really annoying.
So the fan speed is like a function of temperature.
Just really cool. And this graph is core voltage versus processor frequency. Blue is the turbo method, and green is the manual overclock. And what's really cool about this is with the turbo method, you have to like start increasing the voltage really early on to get the computer to boot and work properly. But with the manual one, like we didn't have to increase the voltage until we got to like 4 gigahertz, which is like significant. Like that's higher than like way higher than like this one even got. So like we didn't have to increase the voltage until we got to like right here, and then for 4.4 we had to go like way higher.
And that's higher than the manufacturer said it would be able to go.
Yeah, the manufacturer says that it'll stop at 3.9 and can't go any higher, but we got it to go to like 4.4.
And so this is a graph of temperature versus processor frequency. And for the turbo boost method, it's a linear relationship. And for the manual overclock, it starts linear and then it just kind of goes up like exponentially. But for the linear parts, the turbo boost method has a steeper slope, so the temperature has to increase more per increase of processor frequency.
Yeah, we expected for the temperature to just be like whoosh and end up like way up here somewhere. But it was pretty linear till here, and then it kind of like leveled off for these frequencies, and then went way higher at the end. And then this is test per minute versus processor frequency. What we did to test the performance of the processor was to run this program called Prime95, and it uses like all these complicated methods to obtain prime numbers. So the processor's using all its power to like generate like hundreds of thousands of prime numbers really quickly. So each test is like hundreds of thousands of prime numbers with like these really complicated methods, and like you can run it for 24 hours and it'll do like tons of different algorithms and get huge numbers. And so this shows the diminishing returns that we expected. The blue one's the turbo boost, so like it starts going up and then it like levels off towards the end. Like the performance increased from 3.8 to 3.9 to like basically non-existent, while from like these two or these two, like it's more, you can see it more. And then with the manual one, it's the same kind of thing. Like it goes up really big here and then like levels off here, but it goes up like way higher here because the test went from taking 13 minutes to taking 12 minutes. So we remove a minute from the per minute, like it, like because we took the number of tests divided by the time it did. So when it went, like the times went down from 13 to 12. So the last point's significantly higher.
Okay, so this is the idle power and the load power versus the processor frequency, and you can see that this is the red down here is that the power when it's not doing anything, and then the blue up there is the power under a load, and so it's just, you can see just a huge increase in power.
And it's really cool because like processors like underclock themselves, so when they're not doing anything, they go to like a minimum frequency. So like no matter like how high you have the processor, it'll go back down to the same minimum frequency. So it's using about the same power, no matter like what maximum setting it's on, if it's not doing anything, which saves you lots of power or money, I guess.
And this is basically the same graph, but for the manual overclock. And so yeah, here's the base power again, and then the load power.
And like you would think that these would either be like exactly the same or like increasing slightly, but it's probably due to inconsistencies in the power supply. It accounts for the difference. And then this is max temperature versus load power, and this graph is really weird. But this is also like because the power supply is really weird. So like when we in our raw data, like the power per trial doesn't seem to exactly correlate with how much frequency or whatever. But it seems to go up pretty linearly as the power goes up, the temperature does. And then this is for the manual overclock. It's more linear, but the slope is this is 0.71 slope, and the other one was like 0.9 slope. That's Celsius per watt. So the turbo boost is generating more heat per watt than the manual overclock is. And this went way higher. The temperature in this one ends up at like 66, and the other one ends up at like 59. That's because the manual one's doing like a lot more, like 0.5 gigahertz more than the other. Okay, and then this is an analysis of the processor performance. Initially, it was doing 2.286 tests per minute. And then with Turbo Boost, it was doing 2.923, which is a 28-ish% increase. And with manual overclock, we got to do 3.333 tests per minute, which is a 45.8% increase from the manufacturer standard. And then, so manual overclocking got us a 14% higher performance than Turbo Boost did, and 46% higher than manufacturer, which is really awesome. And we predicted like 20%, so that's like way higher than we predicted. Mm-hmm. And then, this is just like an analysis of the diminishing returns. They both increased a lot more during the first half than they did in the second half. More so with the manual than the turbo. And then we did the graphics code, and that's experiment B.
Yeah. Okay, and so there are two kind of ways this happens. So there's a graphics processor frequency and the is it VRAM? Yeah. Frequency, and so when it's just doing regular things, it uses the graphics processor frequency, and the VRAM is only brought in for something that's really like stressful for the graphics card and like difficult to do.
And then our first hypothesis was higher frequencies will cause the temperature to go up. That should be a G, not a C.
And then our second hypothesis was that we'll be able to overclock it to 20% more than the manufacturer standard.
And this is raw data. The first table is from the graphics card frequency, and the second table is from the VRAM, which is the random access memory of the graphics card. And something really interesting that happened. Well, first let's start here. The FPS is for frames per second, so how many like images you see on your screen per second. And at the default, we were getting 56 on average. And then there's this thing called a power limit of the graphics card, and you can like raise the power limit to allow it to use more power to do things. You're not supposed to, but you can. So we, well, because like the physical limit's like 30 watts, but like 300 watts, but it limits itself at 250. So I bumped it up 20% to make it 300, so it's actually working at its maximum. So it went up from like 56 frames per second to 72 frames per second, which is really freaking huge. And it kind of sucks that they'll just let you use that, like by default. And then we increased the graphics frequency, and it only got like 2 frames per second higher than after the power boost. And here we increased the memory of the graphics card, and we saw like diminishing performance as we increased it, which was really freaking weird. Like, and then like I tried like all these different things like to try to like see what was wrong, and it just like confuses it kind of, because like the frequency it's running at is like the ideal frequency, so like it's most comfortable running at that frequency. So everything up until 1500 we saw diminishing returns, but here we see like it got the firmware score is like a arbitrary number generated by the graphics testing program, so it's only relevant when you're comparing it to other scores from the same program. So at 1500 we see it like it eclipsed the original score, and that's where we ended up keeping it, and we went higher than that and it went down again. Except for these two, but then it like exploded and crashed. So.
Yeah, the firmware score like aims to measure like the performance, but it's an arbitrary number based on the program.
Yeah, everything after 1500 actually crashed while we were testing it. So like it worked, but then it crashed. And this is the score versus frequency. Yeah, like as we get higher frequencies, the score goes up in general. And this is versus frames per second, and you get roughly 60 score per 1 frame per second.
Okay, and so we started with 56 frames per second, and then we got a 28.6% increase with 72 frames per second, and then the final overclock was 74 frames per second.
And like this 28.6% came just from increasing the power from 250 watts to 300 watts.
Mm-hmm. And then we got a total performance increase of 35.1%.
Which is again higher than we predicted with the 20. And this is just showing how much value we got from overclocking as opposed to just like using it. I paid $60 for the processor, and it's working at the frequency of a $130 processor. And then the graphics card is working to the performance of like one that costs $90 more. So we got $160 of value just from overclocking. And nothing exploded.
Yes, nothing exploded.
That's it.
Time for one question?
Oh, I had 2 questions.
Oh, okay.
Oh, here we go.
So how many cores were in the processor?
It's a dual core processor.
Okay. And did you keep the fan speed constant?
No, the fan speed changes as a function of temperature. So as the temperature went up, the fan speed went higher. I didn't have an efficient way of documenting that unless I like looked at it and like wrote it down like every 15 seconds or something.
Yeah.
There's not really like good programs to like monitor fan speed over time.
So that would decrease. Could you go to the frequency versus temperature graph
For the processor?
Yeah.
Oh, that's gonna be that.
So as the temperature increases, the fan speed increases, which it's trying to reduce the temperature.
Right.
Yeah.
But it doesn't affect the blue dots in the same way.
I don't know.
And each of these tests was running for like 15 minutes. So like the case was getting hotter as we went, because like all that heat is kind of just like there. We have like fans blowing like hot air out and pulling cool air in, and then there's the CPU fan cooling the CPU directly. There's like all this airflow and stuff. But yeah, it kind of like the heat's kind of like congregating, because like, you can't get all the hot air out and get like a whole bunch of pressure air. So over time the temperature increases also. Like towards the end of the 15-minute period, you would see like slight increases.
I would like to see the experiment done in the opposite order, starting with the greatest overclocking and moving back down to see if there'd be an effect of that.
We also let the temperature reset each trial to like
Yeah,
to the same.
Oh,
Did
okay.
a- Yeah,
Yeah,
I think
it's-
we let it go
yeah.
back down to 1. I think we had it 33.
The base temperature is like 28 for the processor and then 33 for the graphics card.
Oh yeah, that's
Thanks, guys. What a tremendous amount of data. Thanks again.
yeah.
There's a lot more. And this is raw data from method 1. Something that's really cool about this is like when the processor doesn't have enough voltage to operate, it doesn't boot. So like all the ends you see means that like there wasn't enough voltage going to the processor to like start the computer. It would like try to start and then explode, or like shut down and restart, not explode.
Well, sometimes it would start up then, but then it didn't actually have enough voltage, so it would crash once it started up.
Yeah, so all these Y's are when like it started and then it stopped because it didn't actually have enough power, but it thought it did.
So these are different runs that you've made and you've tested each
Yes.
attempt?
Yes.
Okay.
Yes, and then this is the same thing for the second method, and then these are all when it crashed, and then. Yeah. So these are all our hypotheses for the processor overclocking. Hypothesis A was that the core voltage will limit performance increases of the processor.
Higher, better.
And these are pictures of it. That's what the case goes, and that's what it opened. And the 2 experiments we did were, I guess it's kind of 3 experiments. The first one was overclocking the processor. And we did that, like, the manufacturer gives you a tool to do it, and then, like, there's a way that you can, like, go in and do it manually. And then we overclock the graphics card, too, with stuff. And these are, like, all the tools we use, like, monitor, like, power. Okay, so for our indie lab, I have this person in my family who has a computer, and it kind of sucked. And he wanted me to build him a new one, so I did. But that wasn't my indie lab. And then the indie lab was overclocking it to make it do better, like make it compute better.
And so overclocking is the process of forcing a computer to perform at higher frequencies than set by the manufacturer in order to make it perform.
Voltage and current and temperatures and speeds and frequencies and all that cool stuff. And this is the processor, and that's a picture. You can talk about the picture.
Okay, so the first method was the turbo boost method, and that was just to increase like the base frequency that the processor was using. And then with the manual overclock method, we were actually increasing the number of cores that were active in the processor.